you want to make sure you take the standard seriously. Are you getting me? You see, you would hear some people tell you, rules of differentiation, implicit differentiation, application of differentiation. Those things are bullshit. I'm sorry I have to say they're bullshit, you know. Why I said that is, some students allow that part to stress them, to disturb them, to be what make them feel that this topic is tough. However, we have just established something. You don't joke with standard of something, is that not so? Because if you joke with standard of that thing, it will be difficult to succeed. That's what you said. And then, GMAS 41 is telling you today that every other aspect of differentiation depends on what? So I beg you, dear friends, I'm appealing to you. You want to be sound in differentiation, give yourself 1 week. I'm just making 1 week. I could have reduced it. But let it be that you grab it very well. Are you getting it? 17 divided by, let me give you a 1 week or 5 days, because I usually count my week in 5 days, not 7 days. So that plus minus, even if there's something, I have a setback. Are you getting me right? I can use the other 1-2 days to make up. 17 divided by 5 will give you what? 3 remainder 2, isn't it? So if you are learning this standard 3 every day, in the next 1 week you have learned the 17 standards very well, remaining only what? 2. You can fix in the 2 in any of those weekdays now, isn't it? Good. You're welcome. Are we ready? We're going to start taking these functions one after the other. The first one will be powers of a variable. Sometimes we call it polynomial, but it is not practically polynomial because in this case the power is a real number, which it could be positive or negative or fraction. Are you getting me right? But for polynomial, the definition of polynomial, the power is not expected to be negative. I hope you know that. And it's not expected to be a fraction. But in this case, the power can be a fraction, it can be positive, it can be negative. So we call it power rule. We call it what? Or powers of a variable. So this is what we're going to do. We're going to have function, and we're going to have int dy dx. But before moving on to this, please, I would like you to write something, note. Before moving on to this function of dy dx, I would like you to write note. Note. Given a function y to be equal to g of f of x. G of what? F of x. Now this is a function. What GMAS 41 does is usually to tell students that in every function we have a major function and we have what? A minor function. The major function is usually the one you pronounce first. And the minor function is the one you pronounce next. Which means in this case, this is going to be a major. And this is going to be the what? Minor. And this thing I showed you applies to every function we are going to meet. Now, the definition of dy dx, giving this guy now, are you getting me right? The definition of dy dx according to chain rule, because this major minor interpretation follows chain rule. That is why when I teach my students, I tell them, as long as you are seated for objective case, you really don't need chain rule. Are you getting me right? You don't need it. The major minor already covers for chain rule. And chain rule is the most important rule of differentiation. But here the GMAS 41 is telling you that we are going to use the major minor concept to do what? Conquer chain rule. You will see it yourself as we're moving. Given y to be equal to g of f of x, g is the major function, f of x is the what? Minor function. The interpretation of dy dx is differentiate the minor function with respect to x. And the minor function is what? F of x. You see this thing written here? It means differentiate with respect to what? X. That's the meaning. Whatever that you're asked to differentiate. In this case, I said you have to differentiate the minor function. You have to do what? So I am differentiating the minor function with respect to x. Then times differentiate the major function with respect to x. What did I say? Differentiate the major function with respect to what? X. Are you getting me? So it's going to be differentiate our g of x. Our what? G of whatever it is. So it's going to have differentiate this g. And whatever you differentiate as g, are you getting me right? remember to write the minor function in front of it. Remember to write what? The minor function in front of it. So what are we saying? Differentiate your f of x, which is the minor, times differentiate the major. The major you are going to differentiate. When you do that, please remember to write the what? Original minor function that came with the question. Is that okay? So in full interpretation, the y dx is simple. Differentiate minor, differentiate what? Major. Multiply them. We repeat. Differentiate minor, differentiate major, multiply them. And that's the answer. That's why I tell friends that you see, a differentiation question should not take you more than one line in reality. Just straight on. And in fact, if you are looking at a given function to differentiate, you can differentiate without writing anything. So that's the general approach to the major minor concept. Are you getting me right? And that we are going to apply to each function. But first about that, let's move on to our first one. That power of a variable is a function given as y to be equal to f of x raised to the power of n. Powers of a variable is a situation where you write y to be equal to f of x raised to the power what? N. Where n equals to real number. N is what? Real number. So remember, it can be positive, it can be negative, it can be a fraction. So if I give you a function y to be equal to f of x raised to the power n, what is the dy dx? Are you ready? Remember, these things I'm giving to you as standard, so you're expected to memorize them. And all these standards, they are obtained from first principle. It's first principle that we use in deriving them. But I've told you, you don't need a derivation for what you're going for. For your personal knowledge, you may visit the GMAS 41's channel to see one or two of the derivations. So the dy dx of this guy, dy dx will be equal to, how do we identify powers of a variable? If I give you something and you say that that function is power of a variable, what will help you know that it is power of a variable is that power, true or false? If I give you x raised to power minus 5, it is the minus 5 that will help you know that that thing has what? Power. If I give you x raised to power 2, it is a 2 that helps you to know that that guy has what? Power. The major function there is the power. Is the what? Power. Because in reality, that is what you pronounce first. If I give you x raised to the power of 2, the reading of that thing is squared x. Is what? Squared x. This thing we use to say cn raised to the power 3 centimeter cube. The correct approach to reading it is cubic centimeter. So the major here is the power. Are you getting me? And what is the power here? N. So this is how you differentiate it. Watch. Use that power n to multiply the base. The base is the minor function because this thing is read as nth power of f of x. I pronounce the n first. So use the power to multiply the base f of x. Go to the power, subtract 1. Are you getting me right? Is this thing difficult to understand, friends? Somebody gave you something, x raised to the power 10. And I tell you, just use the power 10 to multiply the base. Go to the power and subtract 1. Is it rocket science? Straightforward to understand, is that not so? But you have not finished. Because what I did here is the major derivative. Is the what? Major derivative. You have to now differentiate the minor. Are you ready? The minor here is this f of x, the base. For powers of the variable, that's how you identify. The minor is the base. Are you getting me right? So we are going to multiply. I've shown you how to differentiate the major. That's from the power. When I'm going to differentiate the minor, now watch. This minor is f of x. We don't know what this f of x is. As a function, it can be anything. It can be what? Anything. So since we don't know what that f of x is for now, when examiner gives us the question, we will know what f of x is. Are you getting me right? So for now that we don't know what f of x is defining, what it represents, all we know is that it is a minor function. So I'll write it like this. Differentiate with respect to x, whatever the minor function is. Differentiate with respect to x, whatever the what? Minor function is. We're going to find out this example as we apply this standard derivative in 1. Example. You are giving y to be equal to x raised to the power of 3. Are you there? How can aggregate our dy dx to this guy. Dy dx. Are we ready? What is the major part of cubic x or x raised to power 3? What's the major part? 3. The 3. Good. And the minor part is what? The x. So you see our f of x is simply this what? X, the base. Am I communicating? So to differentiate following this, we start from the power, isn't it? Use the power, which is 3, to multiply the base. 3 times x will give you what? 3x. Go to the power 3 and minus 1, isn't it? 3 minus 1 will give you what? Dear friends, I think they say differentiation is difficult, is that not so? This thing I did here, is it difficult? So this thing is not difficult, friends. Are you getting me? Now we have done the major part derivative, true or false. But on the normal, have we gotten our answer? Have we done this part? We have not. Times. It's true for this particular question, we don't need to do the minor derivative. We don't. And we're going to find out. The minor, which is our f of x here, is this x alone, true or false? Now if I give you x alone, you know that this x alone is the same as x raised to power 1, true or false? X alone is the same as x raised to power what? 1. And if I give you x to the power of 1, is it not powers of a variable? Is it not powers of a variable? Good. So we are going to follow the same format of differentiating. Say use the power to multiply the base, is that not so? And minus 1 to the power, let's go. The power here is 1 we said, that's x alone there. So it's going to be 1 times x. Are you watching? Then go to that power which is 1 minus what from it? You're going to get 1 times x to the power of 0. You are going to get 1 times x raised to power 0 will give you what? 1 times 1 will give you what? 1 times 1 will give you what? 1. Which means doing this part, derivative of the minor, you are going to get what? 1. The reason is because this thing is just simply x. If you are reading A, B, C, D, when you get to x, how do we read it? Is it x raised to any power? If you are reading your ABC, your alphabet, if you want to pronounce x, is it x raised to any power that you pronounce? It's simply what? X. So the simplest form in which this alphabet can take is what? X. Anytime I give you any variable, and that variable is in its simplest form as you see it in alphabet. Are you getting me right? If you differentiate that guy, you get what? 1. So what you see here, please don't forget, because I won't do any such thing again. Look at the board, please, dear students. Look at the board. Anytime you differentiate x alone, what will be your answer? Will you forget that? Good. Let's take another example. You are given y to be equal to x raised to power 3 plus 2. Then everything raised to power 5. Are you there? Have you identified your minor in that question? Have you identified your major?
Yes.
The major is what?
U raised to power 5.
The major is what?
U raised to power 5.
The major is u raised to power 5. Where is the u there? Did you see any u there? I don't want to hear that word u in this class. Are you getting me right? When I teach you chain rule, just for you to know it, we'll be talking about it. But remember what I said, you don't need it. If you carry chain rule into your exam hall, I don't know what is going to be your fate in solving the question. Don't worry, I'll prove all these things I'm telling you today. Are you getting me as we're moving on? Under chain rule, you'll see. My question is, what is the major there? 5. Are you getting me right? And what is the minor? X cubed plus 2. It is the minor that chain always call u. Are you getting me? Hello? You that say u. It is that minor that we usually use u to represent. Are you getting me right? We are doing chain rule. But I'm saying you don't need that. Because based on my personal survey, gathering statistics from students, why is it that many students do not like differentiation? You hear calculus, they know. But by the time that mistake is being made from O level, like I said, calculus is supposed to be made compulsory for all students. We are supposed to be doing further maths as compulsory subjects in maths in secondary school than general maths. Have you not known that before? So your mind has not told you that before. Which maths are you doing in advanced level now? Is it not further maths? So who cheats who now? In your secondary school, further maths topic covers general maths, true or false? There is no topic in general maths, according to what they call the general maths. There is no topic in general maths whole level that is not in further maths. Are you aware? But there are several topics in further maths that are not in what? General maths. But once you cross secondary school, your whole level come to advanced level. The maths you meet is more of further maths. So if we know this thing, why not we make that further maths compulsory? You see students, they are worried about all this calculus. What is there? The problem students have in calculus is only differentiation and what? Integration. Is it matrix that you're going to say is difficult? Matrix is 1 plus 1. When I was in primary school system teaching, I taught my students in primary 5 and 6 matrix. And they learned it. Look at their quantitative reasoning. There are some of the quantitative reasoning problem they give that is matrix related. True or false? So friends, spread this news. Tell your friends, tell people you know. Calculus is simple. If the only thing we know about calculus, or we talk about calculus, is differentiation and integration. The only reason students are worried about that is this issue of let's U be this and that. And I'm telling students you don't need that let's U be anything. The major mind already covers for you. Let's move on and see how we attack this question. Are you ready? The y-x. We all said that the power 5 is the major, is that not so? And you have this standard already guiding you. You said that the minor is this base, this bracket. Was that not what you said? So we know that this is powers of a variable because it looks like something like this. It follows this format. Am I complicating? So can we now differentiate? You start first by doing this part. Use the power to multiply the base, right? And minus 1 from the power. Are you ready? Are you ready? So you tell me now. You know the power. You're using the power to multiply the base. So what will it be? Bracket x cubed plus what? Close bracket. What will be on top? 4. Have you gotten your answer? Have you gotten your answer? Have you done minor derivative? In this case, our minor is that base x cubed plus 2. So you now go to x cubed plus 2. Stop writing, please, and look at the board. Understand this thing first. Let me tell you something about this guy. Even without writing, if you just look at the board and you grab all these concepts, you have learned it. It's very simple as that. Do less of writing, grab the point, and then once you grab the point, you can now write even when you talk. Come to the bracket, this is the minus, start differentiating. Come to this x cubed. Is this x cubed not powers of a variable? Is it not? So if you are differentiating it, it's not to use the power to multiply the base and subtract 1 from the power. So this will be times. If we do that, then what would we get? 3x for example. So for the sake of wasting our time, let me do this one. You come to this one and differentiate. This is what? 2. Is there any x there? Remember, you are differentiating this guy with respect to what? X. You are differentiating this thing called y with respect to what? X. Anything, whether it is alphabet or number that does not have that x, you are differentiating with respect to. That guy is taken as a constant. It's taken as what? And if you differentiate a constant, it's always 0. You don't think it. Put that in your brain now. Just like I told you, if you differentiate x only, you get what? 1. That one should be something that you have here. And if you differentiate a constant anytime, you get what? 0. So differentiating that, you will get 0. I didn't have the need to do it. I just had to do it for you to see because this is like part of our first question. You see this thing, you have done that the dy dx. That thing they say differentiate, you have done it. Any other thing you do from here is no longer calculus. Any other thing you do from here is no longer what? The main calculus, which is dy dx here, you have done it. Look at it. How many steps did it take you to get the answer? How many steps? 1 step. Here is the 2 steps. They gave you a question and you did this thing. It's only 1 step. Am I complicating? See, it is my duty to make sure I eliminate any threat, any fear you may have entertained. Are you getting me right? Now our dy dx is now equal to what? You will now come here and do simplification. Are you getting me? This 5 cannot open this bracket. Look at the board. This 5 cannot open this bracket. Do you know why? Do you know why? Because of the power. The power is not 1. If the power is 1, this bracket would have opened it up. If the power of a bracket is any other number apart from what? 1. Did I say minus 1? If it is minus 1, it won't even open as it is. It's only when it is positive 1 that the bracket can do what? Open. So here the bracket cannot open. Therefore, this 5 can't multiply anything inside this bracket. Take it to come here. Are you getting me right? It's not going to be 5 times 3x squared. You know this thing is 3x squared plus 0, which is 3x squared. Are you getting me? Just for you to see, let me rewrite it. This can be written as 5 times 3x squared times x cubed plus 2 raised to the power 4. I don't need to do this, just for us to see, because this is like our first question. 5 times 3. 15. Bracket x cubed plus 2 raised to the power 4. This is the answer. Your examiner will never expand this for you. They will never. The option will come in this way. Are you getting me right? Okay, 15x squared. Yeah. That makes me a human. You can forget it. This thing is very difficult. Is that not so? Very, very what? Difficult. Right? I'm asking you, it's very difficult, right? That somebody tells you, go to power, what you have in the power, used to multiply base, then minus 1 from power. When you are done, go and differentiate the minor function, which is the base. So it's a very simple task. Now we are done with this power rule. Let's move on to number 2. The next function I would like us to look at is exponential function.